Hello everyone and welcome to another episode of This Is My Architecture. My name is Kapil and today I'm here with Eyad from Strateq, who is our partner in Malaysia. Welcome Eyad.
Thank you, Kapil. Thank you for having me. I'm a great fan of the show.
You're welcome. Tell us a little bit about what Strateq does.
So over at Strateq, we do a couple of things. We have our healthcare solution and data analytics. We have our data center business here in Singapore and in Malaysia. We have our cloud consulting and implementation company. And more importantly, for the purpose of this show, we have our PRS, or what we call Petro-Retail services, where we provide level 1 and level 2 support to petrol stations across Southeast Asia, whether it's hardware or software support.
Awesome. So let's talk a little bit more about that support business and the support application that you have been developing on AWS. Who are the users and how do they use this application?
So this is what we call our Smart Service Desk platform. And this is basically targeted towards the petrol station operators and companies to help us provide them with support. And the reason why we built this and why we call it a platform is that we wanted to have a product that actually enables us to have multiple channels of input into our solution, whether it was a mobile app or a desktop application or just plain old phone.
Awesome. So you have different user personas there, and I imagine some of them use mobile apps to report problems. Can you walk us through what that flow looks like?
That's correct. So one of the operators at the station notices that a fuel pump is not working properly. So they bring out their phone and they log the incident. So basically they fill up the information. They fill up the information about the faulty equipment, the time, and the location of the problem. And that information would just flow into our API gateway, which is the gatekeeper for all our core solution. From our API gateway, it will go into the ECS, Elastic Container Service, where we process that request, or we call it incident. And then one of our staff would issue a service order. And that service order basically would flow back through the API gateway, and it will go to one of our field engineers distributed across Southeast Asia. They would get all the information that they need, the location of the problem, what is the SLA timing, and how fast do we need to go and fix that problem. And we'll help them track and update the status of that problem. And as soon as these guys finish working on a problem, the operators will get notified that the field engineer is there, the problem is fixed, or you need to make a replacement, or you need to issue a new service order, etc.
Awesome. And I notice you also have some admin users. Do they also access the system through the same API?
Correct. So we have two types of admin users. We have our users who sit in Strateq, who are our, what we call them, support agents. And they just keep track of all the incidents coming in and out. So they make API requests through their desktop application, which will then get them the information from our DynamoDB or RDS, depending on which information they're requesting. And they keep track of everything. They can update the tickets, they can update the operators or the field engineers. Also, another type of users here is the petrol station back office, where they want to see what is our SLA status across the last 6 months or 1 year or last week. And they can also request a lot more information. They have their dashboards, which also pulls all the information out of our database into our ECS and flows back to the admin side.
And I see that you also have an old school telephone icon there and Amazon Connect logo. Tell us what's the story behind that?
Yes, it's actually a funny story. When you go and you build a mobile application and then it turns out a lot of people don't like using mobile applications or smartphones, or some of these operators don't even have a smartphone. So we needed a way to enable them to raise incidents without having to go to their managers. And the way we did it is they basically call our number, which will then go and connect to Amazon Connect, which is just your basic telephony services. And then it will hand off the call to Polly and Lex. Lex is our chatbot that can interact with the user, ask for detailed information, and Polly can narrate back all of these instructions. We also have support for multiple languages in Polly and Lex. Once we've collected enough information and we know what is the incident, Lex would make a call to a Lambda function. It will invoke a Lambda function, which in turn is going to go and invoke the same API that our mobile app and web applications use, flow back into our ECS, sort out the incident, issue a work order, and then it will go back to a field engineer. Another interesting part, which actually was newly introduced by Amazon Connect, is that we can call back the customer as well. Instead of updating status via mobile app, we can issue an API that will go to Amazon Connect, and it will call back. Polly would narrate the update on the ticket. Your ticket has been closed or updated or equipment change, and it will actually call back to the petrol station.
That's amazing. And you also have sensors on field talking to AWS IoT.
Correct.
How does that come together with rest of the...
So that is our future-proofing, if you will. And the reason why we had to go into this is a lot of these petrol stations have some retro equipment that is not very smart. So the way we found that we can fix the problem is using some of the sensors running on a Raspberry Pi, just a simple Raspberry Pi, that has the AWS IoT SDK baked into it. And they just monitor a lot of the equipment at the petrol station, whether it was the fuel pump or your refrigerator or just simple lights or alarms. And as soon as they detect something not normal, they would push a notification to IoT on the AWS cloud, which will then go through the same API gateway that has the same APIs. It will issue a work order if necessary. And then it will flow back to a field engineer to go fix the problem before the operators even know the problem exists. Or sometimes it's just a simple warning to the operator to say, switch on your refrigerator, or your light is broken, or your alarm system is not working. So it could be just a simple notification sent back to the operator.
Awesome. So you're able to do predictive and preventive maintenance by leveraging IoT and merging it with rest of the application.
Correct. So the future of this would be collecting a lot more data and then processing that data, because a lot of the alerts don't just come from a device is broken, but more like this fuel pump has only done 10% of the normal workload. So it needs a lot of data processing. So at one point, we are going to have probably Amazon Kinesis sitting here doing a lot of analysis on the data. And if we do detect something abnormal, then we will push it through the same way as well.
Awesome. Now, some of these pieces are going to come as part of the near future. Let's also look at the past, because Strateq has been around for several years, and you have had customers in industries like the Petro-Retail, as well as some other highly regulated industries. Now, I'm sure some of your customers are open to use this solution as a service of AWS, or some of them might prefer a hybrid cloud approach. Tell us how that works and how your development pipeline handles that deployment in a hybrid environment.
Absolutely correct. Whether it was regulation, like you mentioned, or a lot of the time is just saving costs, because a lot of these big petrol companies have sunk a lot of cost into building their own data centers and on-premise private clouds. So the proposal that we go in with is we are going to develop everything on AWS. We're going to use this deployment pipeline to deploy our application into AWS, with the option to also pull that deployment down to the data center. So the way that works is our developers would write the code, whether it was Android, iOS for mobile applications, or our backend code, and then they would push all of that into code commit. Code pipeline would then trigger, pick up that code, and send it to the appropriate service, which in this case is code build. And code build is gonna, whether if it was an Android application, it's gonna build the APK. If it was an iOS application, it's gonna build the iOS package and send it to the App Store. And more importantly, if it was the backend code, then it's gonna build the Docker image. And then the Docker image gets pushed into ECR, Elastic Container Registry, which keeps multiple versions of our code. The easier way, the way that we prefer to do, is we'll just use this as a service, push our container to ECS, and it will manage the deployment. But in certain cases, like I said, when the customer do have their own data centers, we pull that down into their data center here, and then we deploy it on-prem. And they love this because, like I said, it's always about the cost, always about the business case. They don't always want to go to the cloud. So it gives them the flexibility to choose which approach they want.
That's really awesome to see how you have used the AWS building blocks to gain agility and develop this kind of application, and at the same time being able to deploy that in a hybrid environment as well. So thank you very much, Eyad, for joining us today, and thank you for watching this episode of This Is My Architecture.